Okay, hey, so this is another example of solving a system of equations. It is the same process as last time, but it is a little bit different. So I want to show you another example. So we've got solve the system of linear equations by elimination, right? So the same thing as the last video. So we've got 3x plus 2y equals -2, -6x minus 5y equals +2. And remember, when we solve a system of equations, we're trying to determine the x and y value that work for both equations, right? If we have a two-system equation or a two-equation system. So our steps, again, combine the equations through addition or subtraction so that one variable has a coefficient of 0. That's the process called elimination. So that's what we're asked to do here. Once we get that done, we're going to determine the value of the remaining variable that makes the equation true. Then we'll substitute that determined value for the appropriate variable in either of the original equations. And finally, we'll determine the value of that remaining variable that makes the equation true. Now, if you look at the equations, there is going to be an issue. If I add my equations together, I'll get 3x plus -6x, and that's not 0. And I'll also get 2y plus -5y, and that's not 0. And subtracting our equations doesn't really help either. So we're going to make an adjustment to our steps. So we'll add a little asterisk in. Right? So combine the equations or an equivalent, or equivalent equations. Through addition or subtraction. So what I mean by that is I could take this equation and multiply each side by 2. And on the left side I would then have 6x plus 4y equals -2. Sorry, on the left side I guess I would have 6x plus 4y, and on the right side I would have -2 times 2, which is -4. And then I could just leave my bottom equation as is. Now the important thing is to understand that by multiplying each side of an equation by 2, yes, I have changed the equation. I do have a different equation, but it's equivalent. And the important thing in terms of how it affects our solution to our system is the resulting line is the exact same. So if these two original, if lines that model these two original equations intersect at some point, since this equation has the exact same line, then the lines that model these two equations will intersect at the exact same point. Okay, so we multiplied the top equation by 2, and so we know we have an equivalent equation, and so now in our system we can follow our 4 steps that I laid out in the last video. We can combine our equations, right, through addition or subtraction, in this case addition. Okay, so if I add my equations together, so I'm going to add down, I will have 0x, and then 4y plus a -5y is a -1y, and -4 plus 2 is -2. So this has eliminated my x's. I can write that as -1y equals -2. And now I need to determine the value of my remaining variable, which is y, that makes this equation true. Well, if -1 times y is equal to -2, then -2 divided by -1 is going to equal y. So I get a +2. And then I'll substitute this determined value, right? I've determined that y must equal a +2 into the appropriate variable in either one of the original equations. And that's an important step. So now the original equations, especially since I've modified that top equation. So I'm going to go back to the one that I haven't touched at all. I'm just going to substitute a +2 in for y. So I have -6 minus 5 times 2. So I've replaced my y with a +2 is equal to 2. And now I'll determine the value of my remaining variable, which is x, that makes this equation true. So if it was me, I'm going to simplify a little bit. -5 times 2, which is 10, is equal to 2. I'm going to go ahead and add 10 to both sides of my equation. So I know for sure that -6x is equal to 12. And then if -6 times x is equal to 12, then x must be equal to 12 divided by -6, which gets me a -2. So I believe my solution to this system of equations is -2, 2. Okay, so I want to substitute my solutions, or my solution, into the variables, into the original equations. Really want to check the original equations. So the original equation was 3x, so I'm going to have 3 times -2 plus 2y, so 2 times +2, and I want to see if that equals, it should equal a -2, right? That was what the original equation was. So I get -6 plus 4, yes, that does equal a -2. Alright, so it checks into the original equation for the top one. And then the bottom equation, I'd have -6 times -2 minus 5 times 2. So I get +12 minus 10, and yeah, 12 minus 10 does equal 2. So it checks out to my bottom equation. So since my solution of -2, 2 works for each of the original equations, then I know that that is the solution to my system of equations. Well, I hope this helps. Just show you another, really an extension on this process of elimination. So the main thing that we did is we had to transform our equation so that we could combine our equations through addition or subtraction so that one of those variables was eliminated. In this case, we just needed to multiply that top equation by 2. Right, so I hope this helps. Remember, math is cool, and so are you.